Okay, cool. So I'm gonna continue this hash table. So the implementation is, I mean, in theory, finished, but I think it can, I think I can do more stuff. So for example, remove some of the duplicate code. That would be nice, much cleaner. Also, for example, there's no unit test for actually checking the probing, and also would be kind of cool to do some, yeah, like benchmarking as well, or to start to do it. Um, so let's get going. I'm gonna try to just do this in an hour, under an hour, because it's a little late right now for me. And okay, so let's see where this goes. Um, so I'm gonna minimize that. So I have here the VS Code, and yeah. So basically, for example, there's like lots of little bit of duplication. So for example, like right, like here, this kind of stuff, right? So with the dog is barking crazy today. Sonny, I don't know what's with this dog. Okay, hopefully now I can start recording again. Seems to be kind of like a dog crisis, barking like crazy outside to something. I don't know. And yeah, it's not my dog, by the way. It's a friend's dog. I'm taking care of it. It's been like I think a week almost since I have it. Tomorrow will be a week. It's a lot of hard work. Lots of hard work. Okay, so let's get started. Um, so cool. Let's do this. So for example, yeah, I'm gonna take this thing out here, and let's see if we can say extract function method. This one maybe. Yeah. Okay, so this could be index. I can call it. Okay. So this could be called edit value. Okay, nice. Now remove this. Interesting. It seems like I had collision count here off actually. That's strange. Well, this has to be like this. Um, Let me in fact just okay. That's yeah, it's probably because it never, yeah, I've never like tested, basically tested the probing, because I've never forced it to do the probing. Um, at least, yeah, because then it would have been broken. Okay, cool. So this will remove this. Um, okay, nice. So here I can replace it with a new value. Let me validate that new method. And this will be delta location key and value. Okay. To be honest, I think this could also just be a function. Doesn't need like a could be a instance method, but okay. Nice. So you have more of those things? No. Okay. So that is there. And then I have this insert stuff, which is the same as probing. So I can call this. Yeah, I think I can just refactor this inside here. And I'm gonna do again extract with the function. Let's see here. No, but where's the hash table? Okay, let me see if this could actually be method. Yeah, perfect. So then this will be, let's say, insert item, perhaps. Insert item. Okay, nice. So this will be called index again. And I think this could be removed, because by default it should be false. Nice. Cool. So also remove this. Nice. So I'm gonna again run here test. Perfect. That's actually also a pretty cool thing about having unit tests is that when you're basically doing these refactorings, then you ensure that basically nothing is broken. So that's also like a cool thing. Um, okay, nice. So we have this stuff done. Now let's see what else we can clean up. Um, kind of also want to move this up. Okay, nice. So it's here. I'm just gonna fine. That's insert here, and then I have insert item. Then I have update value as well. Let's also move that up. Why not? Okay, nice. Now let's see here what else. Okay, so here with the probing. Yeah, so this probing here is pretty pretty unique for search, so it can't really be refactored out. Then I have this delete thing. Here, scroll down. So let's see. So delete and search are pretty similar. Home location. We have this. We have this. We have this. Here. And we have here this soft deleted thing. So of course the difference is that search returns a value. This one doesn't. So basically the only similar ones are, yeah, but not that similar either. Let's see, the probing. Yeah, no, the probing is not. It's also different for search. Okay, cool. So within delete itself, we have this stuff. If I can, I'm not sure if this is really worth to refactor here. The load factor. Da, da, da. Yeah, I think that's fine. I mean, I'm pretty happy with that, actually. I think it's fine. Okay. Yeah, I think this is fine. I mean, I can potentially, although I mean, right, create like a function that wraps all of this stuff, like this, like let's say create error and then the error message. This could, yeah, I could make it a little less verbose, but would it bring any real value to the thing? I'm not really sure, because we only ever have like this single error message key not found for deletion and search. So yeah, I don't think it's really worth it. Okay, format this thing. Okay, cool. So, okay, so the other thing I wanted to do here is I think there's also no coverage for updates. So basically here when we are inserting here for updating the value straight away. Although, yeah, okay, cool. So I know I had this thing E2E test last time, but I think at the moment it's kind of, I mean, I'm gonna just delete it for now. I'm gonna delete good for now. So that's testing T. And steal this stuff. Okay, so oops, this is misspelled. Testing. Let's say, oops, this should be actually capital insert. Okay. It should create also the key. So key 100 and then key. Let's put here 200. And now hash table dot search, and I'm gonna say key, and it's gonna be I believe value error, I think. Test search. Yeah, value error. So now and then got. And then I have forced to do this error does not equal nil stuff first, the classical Golang thing, which is really controversial. Yeah, people really complain about it. So let's do this. So t dot rf. So I'm gonna say expected got error, and the error is, let's see where the in the PowerShell. So error is okay. B the value. Okay, cool. Okay, nice. So let's run load test. Okay, cool. So yeah, it does update it as expected. So this thing is working. So now I want to do the probing thing. Okay, so func test probing when inserted. So testing, and then again I'm gonna basically take this thing, copy it, and I think for now, let me see. I mean, I have to kind of experiment here. So I'm also going to take this out here. We have it here as 4. Okay. So I kind of want to, how can I test this? I mean, I can do also some maybe quicker tests here. Um, let me see. It's so the thing has to basically compute to the same hash. So one thing I can do is take this here. So okay, let me delete this stuff or comment it out. I have to kind of brute force here a little bit. Okay, so we run. Okay, so hash is 3. Now what happens if I go like that? Maybe, yeah, I think I'll have to go smaller. Maybe I'm gonna try 5. So that is 1. Okay, that is 3. Let me try again this. 0. Okay, so I got 3 here. Maybe not the smartest way, but let's see. Or the quickest, but this is 3, and I think foo 1 was 3. Yep, perfect. So foo 1 is 3 as well. That was quick and easy. So foo1 is also 3. Nice, I'm gonna move this here for the time being. So I'm gonna reduce, okay, I'm gonna reduce this thing to, I put it to 5. Okay. Insert. Okay, and then one. Oh my god, the dog. Okay, there, and another value 400. So there we should have the probing thing. Forcing the probing. So that means, how can I get the index? Yeah, I'm not sure if I can get the index actually. It doesn't matter. So let me search both of them perhaps. Search both of them perhaps. Let's see. Maybe TB first. No, if it's value equals nil, actually, what? Test search. Ah, okay, I got this thing, yeah, from the condition where I'm searching on an empty hash table. One. Okay. So I know that did probing. I know that but we can't really assert, let's say, because we're not retrieving the index that it computed. Um, but just to have like maybe a small proof of concept. A small proof of concept here in insert. So let me just see here. So do I have FMT here? Print F. There's FMT, yeah. FMT print F, and I'm gonna say key string, and I'm gonna say hash. Yeah, or index maybe. Do that, and I can maybe just make this fail. New line. Hit this again. Okay, so here I have full one. So for some reason, this is interesting because here full one gave me 3. Go. Yeah, your full one gave me 3. Okay. Interesting. I'm wondering maybe if this has to do. And we're gonna test. Ah, still the same. So one thing I want to do is, just for curiosity, so hash GA, whoops, no, sorry, collision count 0, and I can do fmt dot printf. So hash PA. What's up with this? Ah, the hash table. Okay, so let me see again, go test. And I'm gonna say hash key B. Let's see what happens here. But key B will probably have some, of course, a collision. Right? So key B. So here I have hash key A is 3, and then hash key B is 3 as well, which is what I'm getting. I'm getting here. So of course, okay. See, there's actually, yeah, I think this is a mistake here. See, this should be actually. I think this should be here. Ah, interesting. This should be here, I believe. Hmm. Okay, but this is strange actually. Um, because here it will automatically, so it will be collision count here, right? So that's why we're printing here the key, this key hash 4. So we know these are basically here, right? So it's 3, but then when we insert, it updates, it should actually, no, it should actually, yeah, be here because collision count is 0. Collision count is 0. Um, so let me delete this. So I'm wondering why the hell this is not returning here. That's a good thing. So fmt dot printf. So let's do the same thing here. In fact, so here we have home location. Okay, one thing I need to do is actually, I should have done this since the beginning, comment all that stuff so it's clean. So I have this thing isolated here. Maybe there's a cleaner, actually, without commenting stuff out. Let me see. Golang run single test. I don't know. Let's see this one. Okay, go test run. So let's see. Go test run. Oh my god. Psh, forgot right now. Go test // run. Oh my god. Okay. Let's see. Okay, so we just comment this out. So yeah, I have here this thing here. Okay. And here, of course. If I look at that thing too. Okay, so okay, now I know this is working here as expected. So let me now uncomment that and run this. Okay, so this one is the first key for foo 1. And then here I have again key for foo 11, has 3. And then this one, here it is. Okay, so things were working as expected. Key error, foo 111. So this is after the hash collision computed to 2, right? So at index 2. Okay, cool. So that is working as expected. Nice. I can delete this. Um, delete this stuff as well. Comment the code. Nice. So if value is equals me, we will basically throw. Okay. Nice. So maybe I would say so. This would hash to 3. And this would hash to 3 as well. Okay, nice. Cool. So then the other thing I also wanted to do is testing for a little bit of benchmark. Mm, a little bit of of the benchmarking. So let's let's do that really quick. So let's search here. There's actually something useful to annotate. I think okay. Eventually, I'm gonna also before that push this to GitHub. So I'm just gonna say readme.md and I'm just gonna write here unit tests. So if I go run all tests. Okay. Go. Oops, not go run. Go test. And then the name of the test. Test. Test name. Okay. Nice. So that, and then I'm gonna say here like formatting. And actually, this is too verbose. Actually, I could have just done this here. Actually. Same for this. Cool. Okay, nice. Yeah, so what I was gonna do is, okay, I'm gonna quit this thing. And let's say Golang benchmarking. Let's see what happens. Okay. So we have this thing, testing and benchmarking, how to write benchmarks in Go, more predictable benchmarking with testing of something. Okay. Okay, let's just go always for this official docs. Maybe this one. Let's check out this one. Benchmarks. Okay. Mm, functions of the form. Blah blah blah. Testing B are considered benchmarks and are executed by the go test command when its bench flag is provided. Okay. Benchmarks are run sequentially. For a description of the testing flag, see this. Okay, I'm gonna open this in a new tab. A sample benchmark function looks like this. The output, okay, means that the body of the loop ran such and such time at the speed of this per loop, per operation. Only the body of the loop is timed. So benchmarks may do expensive setup before. So benchmarks may do expensive setup before calling vloop, which will not be counted toward the benchmark measurement. Okay. Okay, fine. So I'm gonna basically copy this here, benchmark, and I think what I'm gonna do is I think good candidate would be I think searching for the time being, searching in an existing. So how much time does it take to search on a really 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 huge basically hash table? Okay, so just gonna delete this here and set up. So this is complaining. B loop undefined. I don't know why is it undefined. Mm, why should it be undefined? Mm, okay. Well, this says it's Go version 1.24, which is the latest version. So yeah, probably I'm running an older version perhaps. You can see like Go version. Okay, fuck. Go. Oh, okay. That's without the flag. Seems version. So Go version. 1.22.3. Okay, cool. So probably is this. So let me go select 1.22.3. I think it was 1.22. Where was it? 1.22.3. 22.3. Here it is. Okay. Benchmarks. So I have this thing here. And okay, no, skipping simple benchmark, run through target. Okay, let's see. The benchmark function must run the target code bn time during benchmark execution. Bn is adjusted until the benchmark function lasts long enough to be timed reliably. If a benchmark needs some expensive setup before running the timer may be reset. Okay, so I have to reset the thing. Okay. Okay, so let me just copy this stuff maybe here. Although bn, can I do this? Can I do this? Doesn't like it. Okay, fine. So let me just see what this thing has. I just want to see if it has less verbose. But this seems like a okay, fine. So it seems it has to be like this. So setup. Okay, what I'm gonna do for setup is the following. I think um, let's do what, like 1 million, the size of 1 million perhaps. Okay, and then I have to loop through this thing. So mm, maybe no 900,000 perhaps 900,000. And hash table dot insert and um, searching for, want to search for. Okay, cool. That's it. Let's leave it like that for now. Okay, so now here I call hash table dot search, and I'm gonna say, like, for example, foo, I don't know, 606 or 3,330, 3,300. Okay, let's try that. Doesn't really matter. So here the timer is reset. Okay, it searches, and I also want to say this the classical value error thing. And we can also search. So if um, copy paste this thing. And actually, this is not need. Actually, want. Okay. I don't know what I want here actually. So yeah, actually this same thing. And let's just say here this is like test key maybe, um, or key. Okay, key. Okay, perfect. So nice. So now let's see else how this is. Oh yeah, I have here the testing flags. The go test command takes both flags that apply to go test itself and flags that apply to the resulting test binary. Zero the flags control profiling, blah blah blah. The go test command and control the execution of any test. So go bench. Okay. To run all benchmark, use bench the or this. Okay. Okay, so I can do this. Bench time run enough iterations of each benchmark to take t specified as a time duration. Okay. So it will basically says it will be executed for whatever specified second. So the default is 1 second. And I guess the longer the thing is executed, the more iterations it does, I suppose. Count n, run each test, and fuzz seed n times. Okay, cover mode. Filled, okay. So let's see what other stuff there is here. Shuffle, blah, timeout. The following flags are also recognized by Go test and you need to profile the test during execution. Okay, profiling. Bench print memory allocation. Okay, interesting. Write a cover profile, CPU profile. Write a CPU profile to the specified file while exiting. Write an allocation profile. Okay. Okay, cool. So, okay, let me try this stuff then. Bench. So, okay, so this has to be renamed to benchmark, um, and it has to be existing key. Benchmark, search, existing key. Okay. Go test, and then bench. And what's the other thing? Bench. Yeah, bench this. And bench mem. Now, maybe like that, bench mem. Okay. FMT is supported but not used. Cool, great. Ah, nice. Okay, cool. So it ran all these times, and then 33 nanoseconds per search operation. So basically, was searching for this key that's existing, and then these are like the bytes per allocations per operation. Let me see if I can do this control F here. There's more information on this. Nope, there isn't anything here. So I think it is. So bytes and allocations. You know what? I'm gonna use perplexity for quickness. LLMs are also good at this stuff, kind of stuff. So explain the following output from a Go benchmark test. Let's see what it says. Blah 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 blah. Blah. The average time taken per operation in nanoseconds. The average number of bytes allocated per operation. Yeah. The average number of memory allocations per operation. Again, none occurred. Okay. So what is the difference? Yeah. Okay. Nice. That was pretty cool actually. So I'm gonna, yeah, could this be maybe bumped up? I don't know, 2 million, and then search over like 1 million items. Yeah, nice. Very, yeah, really cool. Um, so the other thing I can try as well to see if it makes some kind of difference is this time. There is like a time thing. Where is it? Yeah, bench time T. So I'm gonna try it. I don't know, like 5 seconds maybe. 5S and see what happens. So that will run the test for 5 seconds, and then this should be a much higher number. Yeah, there it is. Nice. So it's still very quick, as expected, right? Because it's like that's what hash tables are very good at: insertion, deletion, and search. Of course, in that's why it's like constant time. Like the majority of times, because collisions are supposed to be extremely rare. So this is what's basically this is proving as well, this benchmark test. So the other thing I want to do is benchmark um, a non-existing key. That's what I'm gonna do, and that will basically make the thing also do probing. Um, non-existing non-existing key, and that will be, for example, like I don't know, something like that. And of course, this should be new. Nice, cool. So I'm gonna now get these guys, and I'm gonna actually just leave it here to just to one. I think. Cool. Okay, nice. So yeah, quite a difference here. So if I go here to search, so what's happening is that this, of course, there's probably also some collision. I am pretty sure. So just to kind of let's see if I can do this. Test non-existing key. Oops. So I'm pretty sure. I mean, there must be some collision. No, I said non-existing key. So wait a minute. Let's see if maybe. It's doing both of them. Okay, just to be safe here. Just gonna do that for the time being, so it's just quick. And let me just say, like, but I don't have FMT here. So I just want to say like probing. It's gonna probably have spam the console. Probing. Let's see. Or actually, I don't know if it will do. I'm just assuming there could be some collision with some data here, but maybe not because I'm always using the same like key, and then there's a lot of stuff like this basically. Um, so it's probably like getting this thing here immediately. So if I go like fmt dot print line, let's say like cool for example. Yep, it's returning there immediately. I'm just wondering, yeah. Yeah, in this case, I'm not really sure how to force a collision, actually. Um, so I'm gonna leave it like that and just assume that. Um, so one thing that is very strange, though, one thing that is quite strange is I'm not really sure why it takes longer, a little bit longer. That is unclear to me. Yeah, I'm not really sure. That's something interesting. Yeah, but it's not that much longer anyway. Uh, yeah, so I just allocated 16 bytes per operation, um, and then took 63.26 nanoseconds per operation. It'll be interesting to see like why is it taking a little longer, but um, yeah, I'm not really sure. Okay, so I think that's good for today. I think I covered what I kind of wanted to test. Uh, nice. So, whew. And of course, live doing it live. Yeah, it has more overhead as well. Though. You're just sitting down quietly and working through it. But nice. Let's end this one here. Thank you everybody, whoever's gonna watch this, for tuning in, and have a good day or good night.